Coming up tonight, we take a look at the worrying rise in solar installation fires, which are often caused by some very surprising sources. A man sprays solar panels with black stuff on purpose, Vic and Gary get uncomfortably close for a new tool review, and a former fire chief takes on the Electricians challenge.
Hello, welcome to our twice nightly live stream here on Facebook and on YouTube. Hopefully with no technical difficulties, we bring you a live stream that we think is certainly worth tuning in for our second attempt. We've never had a dry run before as we look at our solar panel installations putting our homes at risk. Gordon, what's your feelings on it?
It's a great show tonight. And if you've had a sneak peek already, just a few moments ago, it's getting a deep dive in actually how the fire service handle solar panel fires, and some technology you can use to obviously help in that situation, de-energizing, and some technology you can use to detect them, which is increasingly important, and possibly some things you might be wasting money on.
Okay.
So that might be ignored by the fire service despite the hype.
Oh, okay, and we've got some new data that's out fresh. I think at 4 o'clock this morning you unearthed a document that's only been out for a couple of days. And folks, for those people that will be unbelievably surprised, tonight we've got back Rick's Tool Time. That means, believe it or not, somebody from this couch will be on all fours summoning down the tool from above with the following tool, and no doubt leaving their pride on the concrete floor here at Skipton. And considering there's no script, I almost got that the same as the first time. And also we've got the fantasy football as well as a story about a lady that is addicted to electricians. She can't get enough of them. And believe it or not, with the increased YouTube sensations that are electricians, it's like soft content for ladies of a certain age that like electricians. No doubt they're sitting at home now with a heavy sweat on and some deep breaths as they look into Gordon's eyes, the gilf of the electrical industry, I would suggest.
There you go.
Yes. So who's in our green room?
Well, we've got to, let's have a look at the green room. Can we have a look? Let's just test everything's working there.
Oh, look at it.
More excited now, more nervous trepidation. We've got big name guests tonight.
Who have we got?
Big name guests. I'm starting to find my notes now.
Do you want me to do it?
Yes.
So we've got Spike. So give us a wave, Spike. Spike's with us. The coolest name ever to be in my phone, and will also be the coolest name ever to hit the leaderboard here at Lineside Studios. We've got almost the budget to get to the chief fire officer of London, but we couldn't quite get there, so we actually got Richard, who was just one below into the deputy role, and we've got Alex from PVStop, who's got an amazing product that you didn't realise that you're going to need in many locations if you're looking to safeguard yourself and property. Okay, shall we bring them in, Gordon?
But first, we'll just thank our sponsors.
Shall we try again? We tried this. This where I went horribly wrong, didn't it?
We have got, obviously this show's brought you with the help from Marshall Tuflex. There we go.
Look at this, and in the right size as well.
Of course, Doncaster cables as well, who we have been using in our own solar installation here. We've got the Marshall Tuflex metal containment, and everyone thinks about containment, they think Marshall Tuflex plastic.
I do.
But we use the metal, and we also use the fiberglass on the roof, the
GRP, yes. So when we were up there with Ross, trying to keep up with him was an absolute nightmare, but Ross was up on our roof using the GRP, and it's incredibly great from the point of view, easy to fabricate, incredibly light in order to work with, and of course it doesn't ever get any issues with the environment, does it? But we are putting it to
reasonably fire resistant.
Yeah, is it really?
Yeah, so if the roof was to go on fire, then probably the last thing up there would be the GRP containment.
And I would suggest if there was a fire on our roof, which we hope there never will be, there would be a lot of small pigeons, yes, that would have been incinerated at any one time. Yes, do you agree with that?
I do. Oh, yes. Pigeons, don't get me started on pigeons.
Yeah, okay.
We'll get to another culprit we found out as we got one. But
and also we'd like to thank the great people at Doncaster Cables. Not only did we use the GRP tray from Marshall Tuflex, along with the metal ones, we also used the wonderful PV Ultra, whether we use the 2-core or the 4-core, we've got both here, and they've increased the sizes, so we've got 4 and 6 mil as well. And I think there's a rumour there's an armoured version and all kinds of other stuff as Aaron from Doncaster Cables looks to expand the product range within the Ultra series. We're all very used to EV Ultra, aren't we? But now we've got PV Ultra, and we used it behind us here. So I'm going to try hand cam, because this is where it went absolutely horribly wrong. So I'm going to bring it in and be incredibly surprised to see my PV Ultra just there. Look at this. And for the first time ever, folks, this is a run through. So this is great. So well done.
And all those cables are exactly just the right length.
They weren't when we did it originally, though, were they? We had to trim some of them back because we had an odd one amongst it, didn't we?
And it's good to see everyone is back in. Even Paul Tipton, actually. We were talking about Paul Tipton earlier on.
Because he might might make the fantasy football later on. When we reveal the 4 people in great position. We don't need to talk about how I'm doing here. And for those people that may have not watched the first one, how am I doing? I'm doing rather well because, believe it or not, I've been nominated for International Trades Personality of the Year. Okay, it was a close run thing. They had to throw a coin in the air to see which one of us two has the personality to pull off the award, and unfortunately it came out tails and not heads.
Well, there you go.
Come out heads. You still reckon you're 51?
You're up against some tough competition.
I am up against some tough competition, and I don't mind coming 5th in that list because you weren't in it.
There we go.
So there we go. So thank you very much for being nominated for that. I did mention it once or twice, I think, today. So yeah, just in passing. So as International Trades Personality of the Year, and I am in the final, we'd like to introduce our guests in there. So bring in Spike, bring in Richard, and then bring in Alex. And for some people, you're going to know what questions you're going to get next. But never mind. We might get some visuals to go with this as well. Richard, take a seat. And here we go then. So, thank you. Believe it or not, no one knows anything about you, Richard. So you're going to be given a wonderful 60 seconds. They do know one thing. You didn't get to the top of the career ladder because you got stuck at deputy.
I did.
Obviously, you didn't quite have the to get to the top. But tell us all about yourself, both personally and professionally, with a hint of your electrical knowledge to see if we can help our audience out for later on when they're gambling.
Okay, so I'm Richard Mills, 53. Did 31 years in the London Fire Brigade, started out as firefighter, worked my way through to the ranks to get to Deputy Commissioner.
Missed out.
I did miss out. So my experience is general building, DIY, and also when I've had to deal with it in an operational environment from an electrical point of view. I'm the father of 3 and have a lovely wife, and I've since retiring I now spend most of my time with the family and enjoying myself, because that's the wonders of a public pension.
Yes, so there you go, folks. The final salary pension within the fire service is alive and kicking when you can retire at 53. So just remember that as you're sweating yourself into your 68th year in order to get your old age pension, that some people are blessed.
But you didn't risk your life, Gary.
No. And I always find when we get fire people in, so I've taught a few in the past, believe it or not, I've had firefighters come into my classroom in the past because they have 4 days work out of a month. Okay, that's doing their day job with the final salary pension. They get all this spare time where they can go off and perhaps become Jacko of the brushstrokes. Are you a painter and decorator on the side?
So I've done some secondary employment in the past.
Oh, really? No, shock.
Painting and decorating being one.
Yes.
And roofing being another.
Right.
However, what I really love is the fact that when firefighters go out and get second trades, it helps us in our job. So when I get a problem at an incident and it's a roofing job or it's a electrical job, there is someone there that knows how to isolate and do the work for me.
That's the most horrific answer in all these years I've ever done live streams to get yourself out of a side cash hustle. That was. Okay, so coming over, let's go to you next, Alex. We're going to mix it up for those people who didn't obviously sit through the first one. So go Alex next time. So tell us all about yourself, Alex, in about 60 seconds or so.
Yep, Alex Keene. I was born and raised in the solar industry, following my father, sun chaser, so working for BP Solar, setting up solar factories around the world, developing solar farms or solar panels at that stage. My experience of the electrical industry is limited to retail construction. When I know first fix to final fix, the electricians turn up on site and leave an incredible mess behind them. Generally, I'm responsible for tidying up.
Retail construction?
Retail
Is that
construction.
what we call shop fitting?
It is shop fitting.
I like that one. Gilda Lily there.
Lucky to be given the chance to pivot later on after I finished my retail construction part of my life, and pivoted to follow the inspiration of an Australian innovator who managed to, luckily, unluckily, electrocute himself off a roof after working 40 years in the solar industry. Lucky in that he survived, lucky that he woke up with the idea, if it can happen to him, it can happen to anybody that doesn't have the same level of experience or even with his experience. And his very simple idea was to coin a phrase, the DC danger zone, which identifies that a PV system, whenever the light is hitting it, is a live system. In the old days, they'd throw a blanket over it, tarps, which is now deemed unsafe. So we've now been able to create a modern iteration of the old school practice of throwing a blanket to block the light. And we now have that as a live solution.
Good. And we're going to come back to that. So there's a nice tease in there. But of course, we'd like to see in front of the problem. So tell us all about yourself then, Spike, the coolest name ever. So tell us all about
Thank you.
yourself and a little bit about your company.
So my name's Spike Armstrong, Business Development Manager at Thermocable. So we're a UK headquartered manufacturer of specialist fire detection technologies. Specifically, we manufacture cable-based sensing systems. So the cable itself being the fire detector. Yep. So the idea behind that is you can install it in very sort of hazardous, hard to access environments. For example, rooftop solar arrays, where you have issues with your conventional technologies, either through typically reduced kind of life expectancies or cost. And that's something that I've had the pleasure of being able to drive forward for Thermocable over the last year. So that being my first year in the fire industry. Before that, did a couple of degrees, so PPE.
2 degrees.
Yeah.
Two degrees.
PPE, and then
PPE. There's a degree in personal protective equipment.
Yeah, it's a common question.
Oh,
yeah,
that must have been a really tricky one. Or wear a hard hat and a harness. Yeah. So you didn't do the PhD in it, no?
No, I considered it, eh? But so PPE and then some public policy. So I've had the kind of opportunity to be able to bring that into my current role. So I'm enjoying that. And yeah, pleasure being here this evening.
So you did PPE and then you dropped the E and did PP. Is that right? For that?
Kind of, yes. I did philosophy, politics and economics.
Right.
And then public administration and public policy.
Right, okay. No worries.
Yeah.
Very clever.
Whiffs of electrical background. Secondary career in there, doing a bit of shop fitting.
We didn't get any of this the first time round, did we? Glad we've done this again, folks. That shop fitting wasn't mentioned. Now, what he didn't mention, Spike, was his unbelievable ability to perhaps master sporting activities. You played professional or semi-professional football for both Sheffield clubs, is that right?
Played football when I was younger, so in the academy systems, thoroughly enjoyed that. Then a little bit of field hockey, so up to national standards, and then a bit of rugby. And we were saying earlier, more of a hobby. So if it was a big opposition, I was inside centre, and if not, thankfully a winger. So
you got to academy and England status as well at something else at hockey, didn't you?
Yeah.
That's
Exactly.
pretty good. And we saw that competitive edge, but sometimes people have got all the competitive edge in the world, but when they're in an arena, you didn't look like you'd hold a screwdriver very often. Is that true?
No, I mean, I think it was, very, very interesting looking at me in a white collar trying to do a screwdriver, but I think it went well, so we'll see later on.
Yeah, no worries. Well, we're between a decent tool, so maybe we can press on with the next section then, Gordon. So you're looking at the screen, so stay with us. So I'll keep mugging you off silently and you won't hear them.
It's all right. No.
Okay,
So we're going to look at a little insurance report that dropped in this morning, actually. It was it's on the news today about the number of fires that the fire service are tackling every 2 days. A fire involving solar panels, which they reckon is a 60% increase in the last 2 years.
Okay.
And if we just look at the exact numbers, I mean, we're not talking, compared to the number of solar panels, is obviously...
So we've not got data that says we've installed more solar panels, so we've got a little bit more fires. This is equal.
Well, there is.
rating,
No, there's more. So there's the rate of solar panel. Hold on, just bring that back up, Joe. I just lost that there. We're looking at the... the rate of solar panel increase last year went up by 12%, but the fires rose by 33%. So 171 versus 128 the year before. And then there's a breakdown of where they are. So mainly, I'd say, split residential. I'd say 2/3 residential.
That's frightening.
And a sort of third in sort of non-residential. And then where they come from. So a selection on the panel, in the cabling. There's a few batteries starting to sneak in there. And in the inverter as well.
I'd say that would be alarming figures that they're increasing. It's not like you're looking at some statement for a company listed on the stock exchange and see your numbers have gone up, so we're all doing better. This is not a good place to be in, is it?
No.
That's a short answer. See you in 2 weeks. Okay, so it's not good, is it? So are you having to approach this in a slightly different way now?
So when I joined, 30 plus years ago, this was never an issue, and it was a growing issue as time's moved on, as technologies come in. In my former role, one of my roles was to work for Operational Policy Department, and we were noticing a change of the way in which fires were starting and how crews are trying to respond to solar panel fires. From there, we went and obviously looked at, okay, how do we de-energise these solar panels safely? Because although you can isolate from the switch and everything's isolated downstream, actually the live product is still there on the roof while it's generating obviously DC current through the sun. So we had to look at a system that would then isolate it. One of the big things for us was about training and education, and it always will be in the fire service. because technology is moving at a very, very fast pace. Risks are changing incredibly quick. We were always an advocate of early detection, and then, okay, how do we de-energise, and then how do we deal with it safely as a normal fire?
Good. Now let's look at the next slides as we come through. You can see some horror shows now coming up after we've seen those. So where are we now in the electrical installation, Gordon?
So I've just asked our team electricians out in the field just to send in what they're seeing on a daily basis, and this is someone who specialises in maintenance, so this is their holiday photographs, should we say, when they're out there. So obviously not on the DC side, mains isolator into an inverter, and obviously people forget solar systems, live most of the time during the day, pumping out quite a bit of power under quite a bit of stress, day in, day out, heavy load, high usage, and obviously the classic one, someone probably nipped the insulation under the terminal.
Yeah, so we're looking there, so on the black conductor we see it burnt out coming up, and on the corner section as well. So yeah, as you're looking at that, that's generated a lot of heat, a lot of thermal runaway on that one. So.
Yeah, so that's that one. Then let's have on to the roof. Next slide, please. There we go. Here's an unlikely culprit I thought was quite funny in terms of what do you find under your solar panels? You struggle with pigeons.
I do.
Yeah.
Even though I got told when I put in my pitch of my roof was so sharp that you would not be able to get pigeons under there.
Yeah.
Nope, you can.
You got a flock, and we've now got our own flock of pigeons on our roof here because they seem to have, I don't know, solar panels must attract pigeons.
But we're lucky because they're only doing their business over the half that isn't ours at the moment, aren't they? Which is unlucky for our next door neighbour. So now this isn't a solar panel issue, is it? As such, this is an issue under the panel.
Well, it looks like there's a fire about to happen on the panel. And who was saying? So solar panels, what they're made of? You saying it's plastic on the back, is it?
Plastic backing, but I mean there's glass on glass now, which is starting to be introduced as well. But primarily you've got legacy of PVC or plastic backing,
right,
or EVC.
Yeah, and then there's an issue with maybe people dropping stuff on them. We're back to birds again.
Yes,
so what's the issues with birds this time?
Believe it or not, this was a seagull dropped a rock on a solar panel.
That was some rock.
It was. It must have been some seagull as well. And obviously, like the installer's been up there and left a row of breeze blocks up there as well.
Yeah.
So it's obviously.
So Alex, that panel's now completely useless and not working. Do you agree?
I would agree that needs some serious attention.
But it's doing absolutely nothing. It's not generating any voltage at all, is it?
Depending on the system, it's hard to tell from the photo that's here at the moment, but left unattended, which it's sitting on a roof. How often is that going to be inspected, maintained, cleaned? How early do you pick up on that being a problem?
Yeah.
But left unattended, that won't heal itself. That would just get worse.
And later on, you'll see some panels that all of them are cracked, and we'll be able to see actually how they can generate voltage and how that voltage can get worse, maybe to the metalwork of the building as well. So when you look at something you think is damaged, it doesn't always mean it isn't working. Yeah. So this is hard to pick out. So where is its moment the first time I looked at this one? So yes, it is the only green leaf in there. I mean, what else is there to look at, Gordon?
It is. So nestled in there is obviously a DC solar cable and an MC4 connector, which are the MC4 connectors. I'd suggest, I've looked at a lot of them, they're not original MC4 connectors, but if we see what obviously happened to it, next slide.
Oh, that was a long pause after the start of that today.
And this is flagged as one of the biggest causes of solar panel fires, and it's the MC4 connector, or should we say mismatched solar connections. Yeah.
Laying on the floor next to a load of leaves.
Next to a lot of leaves.
Dry leaves as well. They're good. The green ones are no good, but dry ones are good, aren't they? Bit of kindling.
On top of roofing felt.
Yes.
Yeah.
What more could you want, really? Yeah. So again, we've done some experiments where we tried to make them fail quite quickly, but it does need to be in situ. It does need to have a life sometimes to start the failure process. So you could put an incredibly average connector together that could last some time, folks. And we proved that when we made ours off. But look what happens over a period of time. Got a little bit of dampness in there, thermal runaway, and all of a sudden then we're at a point where we've got a fire and an issue coming up, when originally it probably worked for a number of, insert the years you'd like on that one. So yeah, frightening stuff I would suggest.
Yeah, and MC4 is interesting. So again, a lot of people don't realise MC4 is a trademark owned by Staubli, a Swiss company, and they are the only ones allowed to claim their connectors are MC4. Right. And now, and this is probably where a lot of the problem starts, where people don't realise this cross-mating issue.
At £2.80. So I'm buying the ones that own MC4 from...
So MC4 tends to be fitted on most solar panels.
Okay, yep.
The ones that come out of the factory will have an original Staubli MC4 connector fitted to them.
Okay.
Some of the manufacturers have swapped to their own versions, but you generally don't have a problem when you're plugging panels together because it comes factory assembled.
It does.
Not a problem. It's a problem where you've got the start of the string, the end of the string where you're connecting your cable, or you're linking around an object like a skylight and you've made your own cable up. So you should use the ones that are provided with the panel. If not, at that point you'll have to chop off the connector and put a matching pair on.
Which neither of those are difficult processes, but if you've got a manufacturer's end, I would always like to leave that manufacturer's end and meet it with the right one. However, you can stumble across other well-known online sites.
So this is another website, fan. So again, you put in the word MC4. This is not an original MC4. This is a I guess we'd call a clone. Now, as a system, those two connectors connected together may pass all of the tests because they're as a system.
Yeah, you would think they would, yeah.
But it's when they're cross-mated that's when you get into problems. And this is in the regulations and everything that you shouldn't do it.
Well, this is a better deal because I've got 50% off.
50%
so I'd be
off.
going for that one because it's 50% off. It's not that £2 odd that we had on the last one with the actual connectors. We got it at a £5. Good way to see as well. Is it an orange O-ring? I don't think that should be your only port of call, but an orange O-ring suggests
it's one of the telltale signs. So the original connector always has a black O-ring.
But you could put a black one on one that wasn't original, so don't use it as your only thing that thinks it isn't.
And then the last one again. So again, both these connectors are sold as MC4s. They're not. They're made by alternative companies. Together, probably pass the test, but when mated with another one, they wouldn't. You'd be accepting the liability there. But interestingly, on all of these sites, they're nearly getting on for double the cost of actually just buying the actual original connector.
And these are DC solar connectors, if you want the right terminology. So again, I can see it from their point of view. Nobody walks into electrical wholesaler, I don't think, and says, I want a DC solar connector, because everybody has used that slang of, effectively it's an MC4 connector, but Staubli are the only ones that own that name.
Yeah.
Makes sense?
But time and time again, that is a big cause of fires. And then obviously, it's not just the connector, it's how people crimp them. And I say, we've played around with them and we couldn't get them to we actually found you can quite easily mate them and you don't see any problems.
And we mated them terribly as well doing something.
Yeah, and let's just see, we've got a little video showing what we did on the ones in front of us here. We put an enormous current through them.
So we had to play around with lots of different ways. You saw an orange O-ring going in there, so we're presuming this is not the MC4 from Staubli, but we've put an enormous amount of current through this in order to get it to fail in a period of time. Well, we haven't, as we said, had it on a roof, had it in moisture, had it vibrating under the panel, all the rest of it. But when it does go, folks, on that one. And we wouldn't suggest that's a failure of the connector, would we? We'd suggest that's the amount of current that we've put through it for the visual effect.
Yes, that was, yeah.
Yeah, so we're not trying to hoodwink anyone on there. And I think we did these up with pliers, we cross-mated different brands, all the rest of it, but a load of current through it. And on that day, after crimping, we couldn't get one to fail.
Yeah.
We could stand behind and say, poor practice caused it to fail. Agreed?
Which people probably think, that's fine, not a problem. Crack on, but again, it's that, as we know from our electrical insurance investigator, it's over time, things heat up, cool down, bit of moisture in there, bad gland on there, and then you end up with the sort of things we've seen. So.
Get cooled out. Yeah, yep. Your blues and twos, we're out. Yeah, so and we're flying our way down to a commercial building.
Yep.
Is there any early warning system for those people sitting inside of that engine that they're going to get there and be facing with certain things? So in the old days, we knew the building would have gas and electricity in it probably.
Yep.
Yeah, we turn up now. Is there any early warning systems to say this might have battery and solar?
So it does really depend on the kind of building you're turning up to. So we may hold information centrally about what hazards are within those buildings. Increasingly, people aren't looking at solar panels as being a risk. So are they actually recording it on their risk assessments or putting it in their data sheet? So we might turn up, ask for a plans book, what hazards are in there, are there any regs that we need to be aware of? If we do have solar panel, with standard practice would be, okay, we're going to look to isolate the supply. If we're going to do save life, we will send crews in to do the rescues and have a second crew going in to isolate the supply and ideally de-energise the solar panels. Once we've de-energised it at source, we can then fight the fire as normally as we could. It's all very well switching it off, however it's still going to be live between the solar panel and the switch. Everything else is isolated downstream. It's an inherent risk that's a growing risk for firefighters, so we make sure that we train firefighters and officers in hazard awareness around solar panels and what to do either whether they're involved directly or indirectly involved because of the nature of the fire.
So when we're thinking MCS and we're registering so that effectively the DNOs and all the rest of the network knows we're adding load to it,
Yep.
you don't get privy to that data. So you could just say on the way you're driving now, we've just looked at the database and we believe we've got this, this and this there.
Not necessarily. I think the other thing as well, you've got to think about, people are installing solar panels by themselves.
No.
They're being sold as a product that can be self-installed. You'll get just the same kick and pain out of a domestic solar panel fitting as you would do an industrial one. What I would say, and I mentioned to some of these guys earlier, was if you are a big firm that are fitting a massive amount of solar panels on a big commercial building, then contact the fire brigade, invite the fire crews down to come and familiarise themselves with the building. It's not just about the hazards on the top of the building, it's about where are the fire prevention systems within the building, how do we navigate the building, what are the hazards inside, because it's about protecting the asset inside as well. Life will always be the priority. So that'll be the internal people that we're trying to save, and also themselves. Bearing in mind, hospitals, care homes, and all those kind of places now have solar panels. So we might prioritise and say we'll let the solar panels burn. We will prioritise evacuating these places first.
So I used to teach my students, you go in, the fire service come in and look at the panel. Obviously there's a map, there's obviously zones, and we get to see where the fire is.
Yep.
There's no list down there either saying, there's no requirement for us to say what other generation sources we've got.
So the risk assessments aren't clear in relation to people doing risk assessments. What I personally were always grateful to see as an operation officer was a very basic layout plan, a very basic plan of where are my firefighting medium and fire protection stuff, and a very basic list of what are the hazards in the building. So is it the products in the building? Is the hazards that you have, battery packs, where are they? Do you have solar panels? How do we isolate them? Any information. I don't need reams of technical stuff. I just need to know what the hazards are so I can brief someone in 5-10 seconds. Right, don't go on the roof because until we've got products in place. And that's why the fire service in the UK and in London invested in PVStop, because that was the product where you're not putting tarps over places. You can do it from a distance. And it's not just about de-energising the solar panel, it's de-energising potential failures of any arcing of the framework, any arcing of the building itself, with steel roofs. So it's a product that we made sure that we trained everybody in the London Fire Brigade, and then it went nationally around, and there's about 90% of brigades now in the UK that do it.
What a nice segue. Spike, you're next. So obviously, early detection in a dwelling, commercial building or industrial building will have a fire detection system, giving you early warning of an issue so you can take the necessary actions. Your system is everywhere where we haven't seen it without looking up. Give us the most logical place we might have seen Thermocable before we potentially see it under or around a solar system. Tell the audience.
Yeah, sure. So I think probably the most common place you might have seen it but not recognised it is in multi-storey car parks. So this is one of our largest applications, both in the UK and Europe. What's driving that really is a need for active fire detection to protect and detect vehicle fires ultimately. So cars that are increasingly electrified, larger in nature, more plastic, so your kind of speed of thermal runaway and the peak temperatures are kind of faster and higher. So when we think about how we might detect fires in that environment, some of the variables you're kind of competing with are potentially wind, rain, dust from vehicles, for example, high temperature fluctuation, so in your ambience between night and day. And so it's really thinking about how do you have a robust form of fire detection in that environment that's still easy to maintain and cost effective. So what we manufacture is a cable-based sensing technology. So it's ultimately the cable itself is a fire detector. It works in sort of quite a straightforward principle that we'll walk through a little bit later on. But ultimately what that looks like is running a single run of cable above each vehicle bay within a multi-storey car park. Our controller can support 6 kilometres of coverage. So when it comes to even fairly substantial car park setups, you can cover the whole asset, if you like, with one setup. And what the controller then allows for is if it detects sort of early temperature abnormality, so overheating, fundamentally it's an overheat detector and a fire detector or fire. you then have additional time to be able to do something about that situation. So that might be isolating the particular vehicle that's having sort of an abnormal temperature event. It might be kind of alerting your facility with sounds and beacons, to there being a fire within the space. And it ultimately might be used for automating then third-party technologies to try and isolate or suppress that event.
And we've got a great video, but we're going to hold it because Alex is burning to get involved in this. So Alex, it doesn't matter, we get an early detection system. Obviously, the fire people are going out there, we've got a problem. Okay, it's great. So in the old days, gas, we could turn it off, maybe at the gas stop tap or in the road if we were desperate. We could do the same with the electricity at the point of intake or in the road or at the substation. We could knock those off, okay, and take those out of the building. You've now got solar panels. It doesn't matter where you de-energise, maybe you've got a shutdown system. What is actually happening with the panel and the 1 millimetre of cable that still comes out of it that you haven't managed to isolate? What is happening?
It's a live system, and once the sun is shining, it's a benign static system, and I would say in defence of the solar industry, it is a benign system. It is a static. There's no moving parts. It is designed and engineered to sit up on a roof. It's designed to be exposed to weather elements, but as an electrical power generating system, it needs inspection, it needs maintenance, it needs cleaning, it needs a regime to be able to care for it, to ensure that it operates within those parameters. A lot of the regulations and standards, classifications around the solar industry protect and really focus on root cause. These are the variables, design, installation, commissioning, to get it up to a safe state of operation. But that's where the regulations tend to stop. They don't tend to look at what happens when that asset ages, when it weathers or is exposed to a fault, and then the regulations kind of just step back a little bit. They're not sufficiently well developed from the firefighter perspective, for the first responder perspective, and that's where we realise that there's a critical blind spot, a safety gap in the regulations, which is just simply not being addressed. When you look at it from the firefighter perspective, they go to work in the morning, afternoon, evening, whenever the firefighters start. They have no idea what type of PV system they could potentially be exposed to. Could be residential, could be commercial, industrial, could be utility scale. The same problem exists. Whenever the light is shining onto those solar panels, they are generating live DC electricity. The first point of isolation is the inverter, where it gets converted into AC electricity, and that makes it useful for us in terms of how we can use it in our structures, our plugins, our mobiles, devices, and everything else. But from the first responder perspective, there's just too much to think about. Firefighters are not specialists, they're generalists. They're walking into a situation where they're exposed. So from our experience, and that was developing in Australia, where the solar industry is a lot more advanced than it is here and in other countries, 1 in 3 structures in Australia has solar applied or integrated within the structure. They're already 3rd, 4th generation of solar in Australia. They've taken it, their biggest problem at the moment is what we're doing with the mountain of solar panels. We need to recycle and recommission. How do we do that in an environmentally cognitive and responsible way? So we are playing catch up here, but this is a global challenge. London Fire Brigade recognised this back in 2018. We recognised working with them hand in hand as safety partners, and then with Singapore Civil Defence, New York Fire Department. This is a global problem. We're all facing the same challenge here. The most people exposed to the risk were first responders, not just firefighters, because you've got electricians within that as well. Potentially you've got facilities team members, building, fire wardens, fire marshals. That first responder, the first person to actually go forward when everybody else is being safely evacuated, they're the ones most exposed to the risk. If you phone up, you've got a problem, you call the fire brigades, you've got a problem with your PV system, I've got an electrical fault. You need to call an electrician. We're firefighters. We attack the fire. Now, if it's escalated or been allowed to escalate, it starts as an electrical fault. It's then allowed to escalate to become a fire event, and that's when the firefighters get involved. We recognised very early on, early intervention is critical. You safely manage an electrical event before it even gets the chance to be a fire event. The risk is the same.
Good, because that brings in your technology before we see your technology. So let's see how your cable works on the slide and video that we've got coming up now. So let's have a look at that. So you can talk us through this spike.
Sure.
Here we go.
This is some world-leading research that we've recently conducted in Slovenia, looking at what happens when you install linear heat detection cables on panels with different pitches, different ignition sources, proximity to the cable itself, and then different cable positioning. So what you can see on the left-hand side is different linear heat detection products with fixed temperature activations, actually alarming after an ignition source has begun.
Yep.
So what you can see is that within a number of seconds, so for example 11, 12, 20 seconds, we've actually had cables activate, and that would have issued to your central building management system. Critical piece there is all of those cables activated, alerting you to that temperature abnormality before you had flame ingress around the panels, before you had a multi-panel fire or even a significant smoke plume. All sort of aspects of solar PV fires at the moment, which typically people detect through just sort of walking by a building, seeing something on the roof, and then alerting the kind of occupants. So what this really allows you to do is, before, sort of typically any other technologies can alert you to the fact that there's something going on your roof that you want to do something about, you'll have that alarm, and then you can do something with that. For example, it might be evacuating your building. It's one of the most common sort of, I guess, next steps, or it might be looking to either suppress or isolate. Obviously, the link with PVStop is that it allows you that time to consider going onto the roof, identifying where within your solar asset you've got that issue, that event, and then doing something to isolate it. So what the system does in a quite clever way is you can have 6 kilometers or up to 6 kilometers coverage from a single controller, but you'll have accurate alarm distance location down to the nearest foot and meter. So when you sort of map the layout of the cable across your array, you can actually pinpoint it to a specific panel within your entire system setup.
Giving you early detection.
Correct.
Can we have a look at the
Yeah,
system?
we can.
We've got here, just actually have a
I
look
was
at
going to
this
save it
one, so
because
we know.
obviously we'll come in there. So this is great. So we had a little look at this earlier on, and just for everyone, this is a bit of a Blue Peter style. Shove the cables in. We don't give the battery on the outside and all the rest of it. But just show us what we've got here. We've got a zonal panel here, which I would suggest, from a point of view, it doesn't look incredibly expensive, which is nice to hear for the first time.
No, so it's a very, very cost-effective solution. Part of the reason that we designed it was so that it would, fit into this application very well, to make it a sensible kind of addition to your solar array, so that you have that active detection to be able to ultimately protect the assets below your roof. So what you can see here is this is our control panel. So this is EN5428 approved. It can support 2 zones of linear heat detection, up to 3,000 meters each in length.
Giving you the 6,000, yeah?
Exactly. So we have different product types for different markets. So depending on the product type, that will ultimately influence the zonal length that you can have.
Am I likely to see this one in car parks? Is this the
Yeah,
one?
exactly.
Because that's what I thought. So now I've got some other ones here that look a little bit like they're braided in some way.
Yeah, so this is our stainless steel braid that we typically add in applications either where there's mechanical movement or risk of cable cutting. So thinking mining, for example, conveyor belt fire detection, but then also increasingly in solar for rodent protection and also electromagnetic interference shielding. So you might find your fox nibbling through it, for example.
Well, I didn't think we would, but after today, yes, we can.
So yeah, this is our controller, 2 zones of cable. You have Modbus 485 output, which you can integrate directly into your central building management system. 2 zonal outputs with normally open, normally closed loops for your fault and alarm output. You then route the cable wherever you like along your asset. Typically in solar, that would look like a single run of cable on the underside of each panel, typically across the highest longitudinal support bar. So that captures the chimney effect under the panel. So if effectively you have a fire anywhere below the top of the panel, the rate of thermal runaway is such that the cable, when positioned at the top, will pick it up very quickly.
Okay.
They go into your end of line unit. So this is our termination box. And what you have in here is both fault and alarm sort of push button functionality to test your system and to make sure that it's got continuity. So thinking about your kind of annual maintenance or whatever your regular maintenance schedule is, you only have to, for the entire system, access this particular unit.
Can you put a fault on for me?
Sure. So this is the alarm. So you can see at the moment it's issuing sub 13 feet or 4 meters because we've only got a couple of feet on there.
Okay.
So that's the alarm, and then for the same zone, I can initiate a fault. So what that represents is if you had a cable cut and the controller loses visibility at the end of line unit.
Okay, that's pretty good.
Alex, can I ask you a question? How many of those panels can you connect? Say you've got a solar farm, how many of those can you connect together?
Yeah, it's a great question. So with a solar farm, you can ultimately, using that Modbus 485, you can daisy chain the controllers together, so you can have up to 250 addresses that will then kind of report into your central fire control panel with a single point of contact. So thinking about if you had, for example, a commercial building that had tens of thousands of panels on the roof, you could potentially deploy a number of these systems without, kind of, I guess, clogging up too many addresses in that system.
So just to unpack that. So we've got solar panels on our roof here.
Yeah.
We take that box there.
Yeah.
And we run a cable around. So say we'd follow the cable route that our DC cabling route and make sure it goes past every MC4 connector.
Yep.
I'd probably tie it along the cable or something like that.
Yeah, exactly. So we actually have a number of clips that we provide. So these are all, we've got about 20 different sort of stainless steel clip types that basically mount directly to your solar PV bracketry on the underside, either with self-tapping screws or nuts and bolts, for example.
Yeah.
You can also weld them directly on if you want to. And yeah, you're exactly right.
So that would then pick up if there was a problem with an MC4 connector or the panel was going on fire or...
Yeah. So as part of the research that we were doing, we wanted to look at different ignition sources, one of which was DC arcing, particularly from an MC4 or a kind of faux MC4 connector.
What about foxtails?
You are, quite. I mean, we had a long list of variables we had to prioritise.
We haven't done the fox yet.
No.
Incredible. So we've got early detections in there.
Yep.
Okay.
So I'm just going... Price.
Yeah, so I was going to say, yeah. So it's going to be thousands.
Yeah,
So
exactly.
you are, Ruth.
Exactly.
Just a quick estimate. We will hold you to it, and we won't hold you to it. Sorry.
Yeah. So
Audience will.
for the roof that we have here, like you're typically looking at a few £100s for your controller, and then a few pounds per meter of your cable. So a really good sort of example of the cost and the cost kind of effectiveness of the system is that if you were to look at sort of deploying spot detection, for example, our system per meter is cheaper than the fire-rated cable that you'd be using to link those spot detectors. So, part of the reason that we've kind of been really excited about this application, about bringing it to the market in this specific kind of space, is that what it offers is a really robust and cost-effective active detection system, really, that's truly fit and forget, and that you can, you don't need to maintain the cable, you don't need to go up on a regular basis and look at it, you only need to go to that end-of-line unit.
Can I rephrase that for our audience?
Yep.
It's a fantastic upsell opportunity, folks. That's what it is. Get it in there, get in front of it. Now...
Well, we're saying less than £1,000 we could have done our roof.
Well, no, I think it was 500 earlier.
Yeah.
No, I had a couple of £100 plus the cable, so
exactly.
I'm about 250 now.
Yeah.
What would be the dearest thing to obviously put it in then, Gordon?
Well, it's cost of the scaffolding to put it up there.
Yeah, absolutely.
But we would have done that. If someone had said to us, a few £100, £500, we would have put that in there. And it links into your fire line. Now, a lot of people are mentioning in the comments about shutdown systems and things like that. But the problem is shutdown systems don't necessarily detect fire, do they?
No, they do detect performance changes. So they monitor the performance of the solar system, and they're particularly designed to manage shadowing. So where the performance is impacted by any external variable, they can then shut down certain sections or isolate partially certain sections of the solar system to make it perform efficiently. Now they have developed that technology to improve safety, to be able to highlight that early intervention piece. But the same challenge exists. I think when you find a problem and you see how quickly that problem can materialize, when you're talking about a DC arc flash, you're talking about a significant thermal and electric event. So the electricity power out of a DC arc is potentially vaporizes anything around it, and the temperature is like touching the sun. So
words are great, pictures are better. Let's see that, Alex. Let's see, because it's amazing how many times we do this in the video, because we do it a couple of times and then we carry on doing it because it looks incredible fun as it comes in, and I keep talking until I run out of words and the asset. Here we go. So explain what we've got here.
Difference between an AC arc.
So this is 220 volts AC. The load is on, young man.
Some little heaters there. You don't really see an arc, do you?
Nothing at all.
It's a flesh wound. There you go. And then we're into a DC arc. So again, similar power levels. And this is what you get on a DC arc.
But you wouldn't just do it once, would you, Gordon?
No,
you'd
you
have a
can't
little
carry on
bit,
doing
so-
that all day. This
Yeah.
is the sort of thing you would have out as a
About
teacher,
3
Gary.
times. Would you do it 3 times, Gordon? Would you? You'd have another go. What you're trying to get is that continuous arc holding. Didn't hold, put it back down, and again, and again. Look, now all of a sudden you're not even taking your hand out of shot. There you go, you're a happy person now. And that is an incredible amount of energy.
You'd have that in your workshop, trying to convince people to be an electrician, because that's what I would every day. Now, people are saying detection systems, they're getting more advanced and things shut down and stuff like that. Would that change how you tackled a fire? If you went to a solar panel, it's got optimizers on it.
So I think there's a broad principle about early detection. 2 things. One, it's about, okay, can we mitigate a fire happening in the first place? So straight away, you're protecting both the life risk underneath and the asset. So I would argue, your insurance company might want to be more aware that you've got those kind of capabilities. Early detection means you're going to tackle the incident a lot quicker. You're going to see it and respond quicker. I know, Spike mentioned about that. It can link to a panel. It can then send an alert. Can alert us. We can get there sooner. We're dealing with something that may not have been seen from ground level, particularly in high-rise buildings nowadays. And we're actually there, and we're causing a quicker response, less damage, and we're still able to isolate using PVStop, because all the time that panel is live, we need to do something about it. Once it's detected, it means there's an issue there. You could shut it down and that could be the end of it. If not, we need to think about the emergency response. The other thing is, if we turn up and we've got a first responder, i.e. an electrical technician there, who said, I've gone to the roof, I can see it smouldering, here's a plan, this is where it is, I've isolated everything else, but this bit I can't isolate, that is gold to us, because I then know what do I need to do with my crews and my operational response. Do I need to send 5 people up there? Do I need to send 5 cylinders of PVStop up there? Do I need to request more on? All those kind of things become a change in thought process.
Or Rich, should it be there in the first place? I think
Absolutely.
just one thing I would highlight in what you're talking about, because there's a massive difference between a regular building, a solar system in a field, a residential property, or critical infrastructure, where you've got the safe evacuation of people is challenging. These buildings, structures, we're talking about hospitals, schools, prisons, care homes.
IKEA stores.
IKEA stores maybe as a critical infrastructure, but they're public locations, shopping centres, hotels, arenas, stadiums. I mean, they're all potentially where you're going to have a large amount of people, and they're putting solar panel systems all over these buildings. That's what we want. All we're advocating is we need to focus on the consequences of when it goes wrong. First responder safety enhances their ability to protect the asset. But primarily, early detection, early intervention buys you the time to get people that cannot critically get themselves out of the building. It buys you the time to get them out.
I think we've
That's
got
the first
a
priority.
video showing some people having a go, actually.
Oh, have we?
Let's
This will be
let's have a look. So this is
I don't know if this is critical infrastructure. but-
critical infrastructure, but that's inside the building. This is outside the same building, isn't it? A little fire on the roof, massive fire already inside.
Falling onto no doubt combustible material.
Yeah, so straight away, from me, from an operation point of view, what is their situation awareness underneath? What are the hazards underneath? Is the roof structurally sound? Are they trained to actually apply the product there? Is the product the right product?
It looked remarkable on that was CO2 they were firing back into their own
Let's watch
faces.
it again, because it's that good. Let's have another watch.
So this is great. So we've got the inside footage now. So that looks horrific, folks. Doesn't look too bad on the roof, does it? Of course, we've got a few people there. I think they're dusting it with a bit of sand, and then somebody picks up their CO2 fire extinguisher, having a little bit of a go. Structurally, the roof's getting worse.
Yep.
Yeah, there's more chance of them coming through that roof, obviously, as we go through it. We don't think it's in our country, but obviously it's still a risk to building and life being the most important of those. But one thing I want to make really clear at this point is everyone's hearing PVStop, PVStop. Now, to start with, let's ignore the fact that is going to do something, because people have got this PVStop in their mind as if it's some sort of firefighting thing. Well, first and foremost, the building could be naturally on fire because the electrical infrastructure is amazing. The risk to you is still the same when you arrive. You cannot isolate that.
Yep.
Ignore the fact it isn't the fire. So it isn't the fire, the solar. So PVStop, can it work in that situation if people are thinking it's some sort of fire suppression thing? What is it really doing initially?
Initially, it is giving those first responders an option to remove that risk. So and it's safely protecting the solar PV system, so it goes on wet. So it's fire retardant in its wet state, but it will stick to the panels. Its primary purpose is to block the light.
So turn day into night. Complete darkness will mean zero
Very
volts.
simple. The root cause, all the different variables around different systems applied to different buildings, it's complicated. It's an infinite amount of variables that are being applied here. We focus on the consequences. When it does fail, what's the best course of action to minimise life safety risk and enhance asset protection? That's where PVStop originated from. Look after the firefighters. They can then prioritise, make safe or save savable lives, but also then protect the asset. The defensive position.
It also goes beyond that. So whilst it's the initial response, it will stay there. So when we've got fire investigation, you've got engineers go up there to repair it, it's protecting it. Sorry, I didn't mean to cut across you.
No, it's a very valid point. So it's not just make safe in terms of their own safety, but it's leave safe. So a damaged PV system can generate the same levels of, potentially lethal levels of DC to those that visit the incident site afterwards, whether that's cleaning, demolition, fire investigation. So you've got to think through the whole life cycle of an incident, the whole life cycle of a PV asset when it fails, and the consequences and how we mitigate those. The regulations do not address that in this country.
So say it's an old installation, yep. I've got the cables are dropping to bits anyway, which are still potentially live.
Yep.
Yeah, the connectors have rotted through UV, they've been in the leaves, the fox has dragged half of them out already. I'm not going to give up on that fox.
He is fantastic.
Yep. It gives you spray the whole system up and then you can safely remove all the panels. Say part of a
effectively end of life, isolating, decommissioning is what PVStop can be used for. It can be left in place and it still remains weatherproof and light blocking over 12 months.
I think we've got a video. Let's have a look.
So this is a great case. Nothing to do with the solar systems causing you a problem, but the building could be on fire and you're spraying it to obviously give those firefighters a great opportunity of working on a system that isn't currently live. It goes on incredibly well. We've got a couple of tins in front of us, okay, as it comes in. So,
It's what?
It's got words.
Oh, okay, play it then. We're just waffling.
Here, you'll see the procedure for covering the panels with PVStop and making the solar system panel array safe. Note the number of light globes connected to the demonstration unit, allowing you to see that the system is under an electrical load. This dashboard will measure in real time the reduction of power as PVStop is applied. The first step is to spray PVStop horizontally across the centre of a panel array. Note that even the panels are only partially covered. The output is reduced to safe levels in a matter of seconds and the light globes switch off. The next step is to completely cover the panels, giving you additional peace of mind that the system is totally safe. With an air temperature of 25 degrees Celsius or 77 degrees Fahrenheit, PVStop is touch dry within minutes and creates a waterproof coating. Once completely dry, peel it off, or it can sit on your panels for up to 12 months or until you're ready to reactivate your system again.
How incredibly satisfying that last bit.
I could sell tickets.
The whiff of those plastic lids on.
I know. I could sell tickets just for that bit.
No fire. Absolutely no fire there. I love it. We've got a system that's perfectly installed that electricians do. We've highlighted at the start the number of fires.
And it's non-destructive.
But we didn't highlight the number of kitchen fires, the number of fires in say, commercial buildings or residential. They're more likely to cause a fire.
Absolutely.
Yes, absolutely. But of course, with more and more buildings having solar, we've got to eliminate the additional risk of the building below it being on fire.
Yep.
And that's where PVStop comes in brilliantly.
Yep.
Yeah, I just think it's. Do you carry this?
So, as I said earlier, 90% of fire services carry it. Not every fire appliance in London carries it. We have it on our aerial appliances, so our long reach ladders, which sit in the middle core of London. And they can either go in or out of London, but it's for the officers' training to be aware to request them. However, we can request extra stocks, but when you've got large scale buildings, just like we'd ask them to have fire extinguishers and we'd ask them to have other fire safety measures in place, we certainly wouldn't discourage saying, actually, if we know that product is on site, we'll use that as an additional firefighting medium for us.
Oh, sounds like another upsell for the contractor here.
And we could get to a point where we've got people within a building that are trained to tackle small-scale fires. They're fire officers. They take control in the event of a fire. We could find a situation where, if safe to do so, that they may put their own PVC there. I've got a C in it, PVStop in there, okay, in order that they mitigate the problem before you arrive? Is that a possibility?
If they're appropriately trained, just like you'd say about using fire extinguishers, if they're appropriately trained and they know how to apply it correctly, and I'm not obviously the expert at that, that's Alex for it, but to come down and say, we know it's been involved, we've isolated it, or we've isolated it so you can fight the fire in the floor below, then that is a massive help to us. But we'd only encourage that if they were suitably trained and safe to do so.
Just to elaborate on that point, I mean, we've had the benefit of nearly 15 years working on this particular problem and the challenge around it. That window of opportunity before the firefighters even turn up. And that's where early detection can be great, but if you're detecting when the fire's already progressed and the solar panels are already on fire, you've got limited options. You're going to take a decision on whether total building loss is an acceptable fact, defensive perimeter, stop the fire spreading to adjacent properties, but it's a controlled burn. Getting there early enough before the firefighters turn up, that's early intervention. Early detection is a great way of making that happen earlier. But just to be very clear, there isn't one solution that can fix all the problems around PV solar safety. That's why we then, working with London, Singapore, New York Fire Department, we identified that safety process. Early detection, you've got to start with education. You've got to educate people that there is a risk. The solar industry, to be fair, and the electrical industry have been great at educating the end user, the asset owner, where the risks are. It's called the solar coaster for a reason. They are chasing and making hay while the sun shines. There's a lot of money to be made.
Making electricity while the sun
It's always
shines,
the next one. They're focused on the next 100 gigawatts that has to happen, forgetting that we've already got the best part of 180, 200 gigawatts already installed and aging and being weathered and potentially failing, not being looked after, inspected, maintained. We're too forward thinking. We've got too much legacy to worry about, and we're not addressing it in the proper way. Our regulations and standards are lagging on that whole safety operational protocol.
I'd also add to that the data that you showed about actual events. What we are not good at capturing, and we're doing a lot of work within the fire service industry, working with people from other industries, is about those near misses. So those events that have occurred, that there has been a small fire and it's extinguished itself or something's happened. So we're not getting a true reflection of the data. We're only being seen, well, these are the fires we attended to, which are the data used, not all those near miss fires or events where maybe an electric technician has turned up and thought, okay, well that was a near miss. We'll take that panel out and put it back in. And that's the key, that everything is data driven and insurance driven. So if you can demonstrate, well actually, the percentage of installation and the percentage of failure or uplift of fires, there will be data sets behind that telling you something else is going on as well. How are we ensuring that is a common data set that's being shared with all the industries involved in it to help then shape legislation, shape building regulations, shape detection, and ultimately shape how we then train people to say, look out for these issues.
I need to add a point to that as well. BRE, the Building Research Establishment, published their global forensic analysis of PV incident data. That came out in 2017, which is brilliant. It's still referred to around the world as these are the primary causes. My question to BRE was, why did you stop? Why did you stop capturing data? And now I've been very lucky through the FIA, BRE, MCS are involved, Solar Energy UK are involved. We've got data contributions from the electrical industray, so CertSure, so Electrical Safety First, DCA and ICEIC. They're out there collecting data, not just on directly PV incidents, but those good catches near misses. There are good practices. There are a lot of underreported incidents where the right decisions have been taken on site and they've stopped the problem progressing and escalating to being a fire event. We need to capture and celebrate those. Technologies like early detection, like Thermocable, and there are others, I'm not just naming one, but there's a lot of good thought and thinking being applied out there, but it has to come back to that data.
Do you know any other PV stops so you can mention them on top of it? A golden opportunity just to say you're the best and the rest of it, just threw it in there.
No, I don't, but he did mention the best Lewden actual manufacturer. But
I can peel it off and use the panel again. Agreed? So it just comes off, no, you ain't going to be scraping. Yeah, absolutely. No scraping, nothing, it will just peel straight off.
It's a water-based acrylic polymer. So in sub-freezing conditions, it will land and freeze and stick. But then you take it off with a plastic scraper like you would with a windscreen.
Okay, but that one seemed to just peel straight off. Because
That was in Australia, that was plus 20 degrees.
Brilliant. However, now we'll go back to the place where everyone was. It's the panel caused the fire. And now I'm coming in, I'm going to spray some PVStop on top of it. Is that going to help the fire continue to burn, or is it going to help reduce the risk of fire? Is it going to stop the spread of fire? What will it do when the panels are on fire?
If the panels are on fire, there is one short video clip, I think, where you can start the combiner, but I think it's important to say the water-based solution is fire retardant in its wet state. It's non-conducting, so the acrylic polymer stops the ability of electricity to flow back up the stream, which was a concern of firefighters, which you can get round by adjusting the nozzle, the spray pattern, so that electricity doesn't travel back through the stream. But we've engineered PVStop to be non-conducting, anti-arcing, and then it's non-flammable when applied. So it will take heat directly, or it will protect the panel but it won't stop a panel that's burning from the inside. So that fire retardant nature will put out the fire of a burning solar panel. It will also encapsulate the toxic nanoparticles that are released when a solar panel burns.
Oh, wow.
So when solar panels burn, I mean, it's proper breathing apparatus. You do not want to be downwind of a burning solar panel or farm or anything that's burning solar related. Well, that's a toxic release of gases. So that can generate something similar to silicosis, which is like asbestosis. I mean, that's proper nasty.
Hardening of the lung.
So it's
Well
not
done. So it stops that as well. Yeah.
It can stop that by encapsulation. Yeah.
That's brilliant. We've got another video where we've got some broken panels. Let's have a look at this, because this is the bit where I was incredibly surprised what happened with this one. So I think we've got to talk over this one. So
a common misconception is that solar panels stop working if the panels are damaged or broken. In this demonstration, we've connected a series of 2250 watt solar panels to create a 5 kilowatt solar system. If you look closely at the panels, you'll notice that the glass in each panel is shattered to simulate the damage that might be caused by an event such as a hailstorm. Next, we connect a voltage meter and an amperage meter to the array to measure the electrical output. As you can see, even though every panel in the solar system is damaged, the system is still producing over 650 volts open circuit and nearly 9 amps short circuit current. This is a lethal amount of DC electricity, as you can see by the electrical arc we're drawing between the positive and negative wiring. This demonstrates that even when every panel in the system is damaged, solar systems continue to produce potentially lethal amounts of DC electricity. Even when seriously damaged by fire, solar panels continue to be a serious safety risk. Next, we connect the voltage meter and the amperage meter to the solar panel frame to determine if the damaged panels are leaking electricity onto the frame. The voltage reading is only minor, at between 12 and 15 volts, which poses no serious threat of injury. To simulate rain associated with a hailstorm or water being applied to an incident involving fire, we then apply water to the damaged array to see if water conductivity affects the amount of electricity that leaks onto the solar panel frame. The impact of water is dramatic. The voltage on the frame immediately jumps from between 12 and 15 volts up to nearly 300 volts, creating a potentially life-threatening risk. If the frame arcs onto metal roofing, this can electrify the roof, guttering, and ladders leaning against the roof. This demonstrates that when responding to incidents involving damaged solar systems, such as clearing stormwater damage in wet conditions or attempting to extinguish fire with water, there is a threat of exposing emergency services personnel to unanticipated risks. In events such as short circuits, fires, floods or storms, PVStop is the only fast, effective and safe way to shut down solar systems and mitigate the dangers associated with rooftop solar systems. PVStop, making solar energy safe.
Interesting there, didn't we? We took a very small voltage and a very small current. We come along with our water fire extinguishers and we managed to make the problem a lot worse, didn't we?
A lot worse.
Yeah, okay. So we can see the absolute benefits of your system, whether there be a fire on the panel. Hopefully there won't be, because we've installed them all fantastically well, but order that you can go in. But fire detection for me now in a modern installation starts maybe at the inverter that could have a problem. That's full of MC4 connections and electronic components, all the rest of it, and the cable run up to the actual panels themselves. Is that something that Thermocable would be involved in, or is it just the roof you're interested in?
Yeah, no, you're exactly right. So part of the thinking behind our system was that it would provide sort of full system coverage across your entire solar PV architecture. So I think it's a misconception, if you like, that it's just the panel itself that might have a sort of intrinsic ignition source. In fact, actually the more common kind of ignition sources around your connectors, they're in your cable tray, they're in your converters, sort of single points of failure, if you like, where you could ultimately have an arcing event or an overheat event that will cause an ignition source. So what you can do with our cable, and the kind of real benefit of it, if you like, is that it can be installed directly at the point of risk. So that risk will start at your, for example, your building control panel, your inverters, your cable trays, your DC cabling on the roof, your MC4 connectors, and the panel itself. So what we kind of look to do is really install the cable across all of those different risk points to maximize the amount of risk mitigation that the system can provide. And that's something that really, with conventional kind of alternatives, you can't have that level of coverage.
It sounds like the best solution that I can think of. Do you agree, Alex?
I do. I do. There are other.
He's still going. Are you two in the same hotel tonight? Or we buy beers for yourself only?
I think what's really important to identify is that we need to play nicely together to deliver a consolidated, comprehensive solution. No one solution on its own.
You need that installed everywhere, and you need one of them by the door. Yeah. So when you've had an alert, you walk up there with a spray.
For the enhanced safety that certain buildings, customers will want, then yes.
Yeah. I would say that you're getting a granular detail on a fire from that system.
Yeah.
On a conventional one, by the time a normal sensor's triggered, the fire's already well in progress.
And I think that's the real benefit, is because fundamentally this technology is for detecting fire, but before that it's an overheat device. So, the idea being that across a very large asset, you can provide very accurate data points around where do you have rapid temperature abnormality occurring, often pre-combustion, but allowing you to then do something about that situation. So, for example, isolating with the likes of PVStop before you actually have that kind of single panel fire and then multi-panel fire develop.
That has to be really appealing to the insurance industry, surely. That actually we're protecting the asset before it becomes a problem.
Yeah. Exactly, and I think exactly what you were saying around kind of what's driving the growth of the adoption of this type of technology in the space, and I think one of those drivers is very definitively insurance. I think to date there's been a lot of focus on the sort of internal kind of combustion risks within a facility, and less so on what external assets are mounted, to the roof, for example. But I think the video that you walked through is fantastic, where it was a relatively small fire on the roof that you then had ingress into the main facility. So fundamentally, what this kind of represents is, a highly robust and reliable, cost-effective means of asset protection for your rooftop array, but also protection of kind of your occupants within that space.
So I'm thinking from a corporate point of view, I'm sitting here thinking I can demonstrate to my shareholders, my investors, my owners, I'm going to protect your asset as much as possible. Should an event occur, I can either detect it early, de-energise and fight the fire early on, save life, or not have any of those in place, lose the asset, lose the job, potentially be in an inquiry or in a coroner's inquiry about, we had all these facilities out there but you never actually applied any of them in the industry. Why not? And you could end up finding yourself in a very difficult situation.
You're a fun sponge, aren't you?
I am, but that's the reality. That's where I've operated in my life.
Yeah.
At the end of my career, that's the environment I was operating in.
So there's been a fire, and say someone's tragically lost their life.
Yeah.
People will investigate the decisions that happened way before that.
So all fatal fires that go to a coroner's court, the fire service has to represent, and we have to talk about time of attendance, what we did, why we did it, and that's part of the inquiry. And that's from a fire service point of view, but you turn it on its head, if that is a business premises, they then say to the business owner or occupier, why did you do this, why did you like that fire exit, etc., etc., etc.
Yeah.
So that early detection and suppression and making it safe for your first responder before they went and leant on a frame or put a ladder against something, that is all about corporate protection and company protection.
So what they'll say is you should have watched this edition of eFIXX TV. You would have found out about all these solutions.
Okay, yeah. Talking to first responder, we've got our very own in the form of Rick, and it's time for Rick's Tool Time. Bring it on.
Tool Time. Earlier this week, tragedy hit the workshop. My trusty tape measure took a dive from the top of a flying carpet, don't ask, and met a rather undignified end. But just as I was sweeping up the pieces, the Sigmund CD80 laser tape measure arrived in the post here at Lineside Studios. Coincidence or destiny? Calling from the tool bag. The name gives it away. The CD80 can measure up to 80 metres, but that's just the start. It can also work out the area or volume of a space in seconds, and if trigonometry wasn't your strong point at school, let's be honest, whose was? It'll even handle the missing sides of triangles for you using the Pythagorean function, but there's more. It's got a built-in bubble level, which is genuinely handy if you're knocking in fence posts, or, more importantly, checking your pub table's level before carefully positioning the drinks. However, perhaps the most useful feature, why at least the one we like most, is the angle finder, or, if you're from 1960, the protractor. Now, the last time I tried this using the built-in function on my iPhone, people laughed, and rightly so. Risking a £1,000 phone just to bend a bit of conduit is, well, daft. Thankfully, the CD80 is a little more sensibly priced. I'll leave a link in the description so you can see if it fits your budget. Right then, let's put it through its paces and bend up some conduit like a pretzel. Gaz has asked me to do a double set in this conduit. He's told me 600mm in length, and this mark here should be 150mm in length. I've got this Sigman laser distance meter here, so let's double check it, shall we? We'll stick it on the tape measurement, pop that on the end there, and then fire it down the wall, and we've got a measurement of 604. Not that bad actually. Now I'm going to use the Sigman and its magnetic base just to hold on to the conduit. At the moment you can see it's at 4 degrees. Now conventionally you'd think about putting 45 and a 45 in, but on this first bend you want to be putting 30 to 35 degrees into the first bend. So now that I just moved through the 0 point, I actually need to get to 30 on the screen, which should give me the 34 I'm after. So Gaz is after it to be 70mm off the surface. There's our first angle, which is 28, let's call it 29 degrees. Let's flip it over to this side, stick that on there, and let's bend that till we get to 29 degrees, which should mean they're both parallel. 28.66, so look at this, 29, that'll do me. It would be nice to have the option to zero the angle. That's one feature missing from the list. The measurements and functions are clearly displayed on the LCD screen, which you can flip between light and dark mode if you prefer. And if the constant beeping drives everyone around you mad, you'll be pleased to know it can be silenced. You can set the measurement units to millimeters, centimeters or meters, or if you still think it in old money, inches and feet. If your memory is like Swiss cheese, don't worry. The last 100 measurements are stored in the device. It just won't remember where you were when you took them. The CD80 runs on a built-in rechargeable battery that tops up via USB-C. There's also a delay measure function which we're still trying to find a use for. If you've discovered an application, perhaps something fast growing, let us know in the comments. The CD80 comes with a pouch and a stretchy lanyard, handy for keeping it close at hand or stopping it from vanishing behind the workbench. Now, if you're new to the Sigman brand, we've been using their CM701 laser level for a few years. It's been a permanent fixture in my van, or at least it was, until this new version turned up. You can check that one out in the video on screen now. The CD80 though, compact, clever and surprisingly capable. It measures, calculates and levels with ease, and best of all, I no longer have to risk my phone bending conduit. So give it a look and let me know what you think in the comments, but till then I'll see you on the flip side. Ta-da.
Mug. I like it. Mug. No, you know Mug, Alex. So we're obviously under here, and it could be a clue for what happens later on when we do the Electricians challenge, or it could be Gary's usual little red herring. But of course, we've got the word tool. Now you've got to fill it in the back of your throat. Okay, can you feel the tool in the back of your throat?
Breathe.
Now I need to, like the dove from above. You've done it before. You've been practicing this off camera. I need to give it the biggest tool to see if we can get it down. Alex, together. We're gonna go. We're gonna go. We're gonna go. And now, tool. So the bag determines how good the tool was. And I would suggest your tool is incredibly stuck in your throat.
Okay.
Okay, so now get it out.
Shake it out, shake it out.
Okay, imagine it's a nice warm day.
Okay,
It's the biggest tool you've ever had. Here we go then, folks. I reckon this time it'll move a little bit. Unbelievable delay. Like the person was in Australia that heard the tool. Eventually the signal got to them, didn't it?
Brutal.
Now I've got a feeling quite quickly on this one, Alex, that I reckon we've got it in us. Yeah.
Let's do it.
Have you got a tool in you?
Let's do it.
Let's get it. Let's go. Let's go.
Ready?
You've been one of the best.
Get in there.
So drop it out. So I just need a quick decision on Rick's tool time there. So you're going to take the tool and you've got the magnetic board. You know how it works. So as you walk towards the board, this top sort of left-hand corner, that would be, what number would we suggest was up there from your practicing?
Do you know, I was leaning towards 6, 7, but I'm going to go with 8.
Okay, so
8, solid 8. Very impressed with that.
Rick was very impressed with it as well. Okay, so there's 1 or 2 things in there we think that we'll learn a little bit more about as we go along. So it's gone up there. It's our Sigmund, okay, detector. Thanks to Rick for Rick's talk. And while we're here, we've got another guest over here. So this gentleman over here, his wife, is addicted. She is absolutely addicted. And I've only got... No, she isn't. She's just generally addicted to electricians, isn't she?
To me?
How many electricians has she dated?
A couple.
You said 3.
Me being the third.
Oh, right, okay. And how many is she married?
But it's more important.
Have you ever had electricians around your house when you're out?
No, not that I'm aware of. I hope not.
So Phil's with us today. Phil's part of this. So he's built this Niglon rig for us for eFIXX College Connections Roadshow. So he is Test Rigs UK. And if you happen to need a rig like this or one of the many you've got in your catalogue, just contact you on the website and you can obviously peruse. Yep. And then from that you can work out whether that fits your college or learning setting. It could be that you're at a professional establishment, unlike a college, because they suggest we're the cheaper end of society. It might be a private training provider. Does that feel like you're going to a posh school when you go to that?
Sometimes, yeah.
So, do you believe your wife is watching tonight? And do you believe she might have a little soft spot? Now, don't mention any other types of spots, but a little soft spot for old Gilf over there.
Possibly, but who wouldn't?
No, look at him. Yeah, he's got the face that every granny could love. So Phil's joined us today, so we thank him for that. So we're back into the show, folks. We will be back with the race. We'll right at the end. If you want to stay on for the next exciting bit.
Next bit of race ball game.
Oh, we go next straight in. We're straight into the race. Well, you threw that one at me. We're going for the race. We don't know the times. We know they were useless, but you need to get your bet in first, don't you, Gordon? What do I need to do?
You need to put in the name of the person and the time that you think they completed the challenge in. So get those times in there. We'll see.
Run through the names again then, Gordon.
We've got Richard, we've got Alex, we've got Spike.
Yes.
So it's Richard, Alex or Spike. That's the first thing you need to do. Pick a name.
Spike.
And then
I just want to write it in.
Time.
I voted for Spike. Spike's going to win. Spike. Yeah, it doesn't mean he's going to win, but I just have to go, I've just voted for Spike, third place.
Remember, obviously, one of our challenges used to do a bit of shop fitting. Or what's it called now? What do you call it?
You said that.
Retail construction.
Retail construction. We're going to remember that. We're going to that's baked in now.
Retail construction. I won't remember it. You will, but yeah, wide variety of skills. We're going to have all 3 race walls, and obviously the fastest time will win. We've just gone a bit stuttery this end, and hopefully that's not an issue.
People think Alex is going to be the fastest here.
What do they?
Yes, it's Alex.
Because Gary's old red herrings.
Spike.
So yeah, we've all been spiked by that one. Yes, so folks, we're off and running.
Oh, there we go. We've had a spike in.
Yeah, get a spike in. Pick the youngsters who've got no idea how to use a screwdriver. And maybe the bloke who's just had a tool in his mouth will now have it out in his hand. So let's see who's up first. Will it be Alex with his tool? Yep, first it is deep breath moment. We're going in. Wave! Instant solar panel. Hey! Wave! We're all off and running at the same time. How fantastic. So let's see what we're doing then, folks. So we're wrapping and strapping and trying to get them up the tube. Now, this was an event, I would suggest, because I was in the room for this. This might be the fastest man ever to wear a shirt that looks like it can be more adorned to a polo event when we look at Spike's attire. But we've got to say that Richard was incredibly competitive. Now, solar panel.
Dangers of solar panels.
Dangers of solar panel. Proper full moon on the back of the head.
Fire.
We say it's 50% roof off when there's a fire.
Jeez. Now, a little bit more methodical. He is probably the wizard of this, the Harry Potter of the wiring systems. But look how quick Richard's going. We did ask him whether that was an expensive watch. He suggested it didn't. And the Disney-style hands on the mouse were obviously part of the... Was it a gift when you left the fire service?
It was a retirement gift.
Yes, so it was Mickey Mouse watch. No, nice and steady here from Spike. No point. Way! There it is again, gleaming away. You'd put some PVStop on that, wouldn't you? Trying to get the sunlight off that one. Now, meanwhile, back at the trying to get it up there. We had a few attempts, didn't we, Alex? Yeah. Getting it up was at your age horrific, wasn't it?
Sometimes horrific. It's worth taking your time.
Well, you took an eternity. Yeah, I know.
It through there as well.
So no need to rush. Just get on with it when I can. I've just got a bit of Cumberpatch about in there. Any Benedict? Is it a Benedict Cumberpatch? I'll never. Hey, there it is again.
Solar panel. Bald patch.
at that solar panel.
It's an advert every time.
Oh dear. So meanwhile, back at the Alex attempt, it could take some time. I don't know why he's laughing. Look how much copper's on show there, and just slow and steady wins the race. I could do this at Eton if I had a chance. And now we're in with a look. You're already on the socket. You're flying here, Richard. Your first run, I was uber impressed. No rush.
What's going on here?
Where are we going?
Just get it right first time.
Yes, there we go. No point. It's not a race. It's not a race. And here we are, down at the socket area.
How messy it is under
No
there.
point rushing
Shocking.
here. And this one's going to be going for it. Definitely going for it. That watch looks cheap. He's got a Casio on it. What is it made? Who's it made by? I can't see any of that. It ain't a Rolex. It's not a Rolex, is it?
No, it's not.
Not a Rolex. I said that. It's not a Rolex. And you agreed with me. You say, you're right, Gaz.
You're right, Gaz.
It's not a Rolex. Here we go then. So a couple of CPCs away from connecting up. It will look like a photo finish, no doubt, but you've already got a whiff who's quicker at this one. You got a little bit slower towards the end. You started off very well. You never got any quicker spike when you did yours. You were slow the entire time.
Look at that.
Yes, a little bit of a pan back to that moment. Fold it in and way, there it is again. Hey, whoa.
Socket on upside
Whoa. You mentioned Australia. What's going on here? What's going on here?
I never saw that.
And yes,
I did that on purpose, just saying.
there's Benedict. So he's back on there, so it's fine. Yay! There it is again, folks. Solar panel.
Love solar panel. You can't beat solar panel.
Not a problem at all. Alex is drifting in at the end, and here's Boat Boy. Come on, up we go.
I reckon Spike's got it, I reckon.
Well, I think that's somebody who's incredibly competitive suggesting that. So, 3 different times, 3 different people. I don't think it's hard to work out who was absolutely useless in that, and I do not want to give away any clues. How do you think went, Alex?
I'm on that wall.
You think? Okay, so can I have the other camera that somebody swiped it off me so I can be the other person? Cheers, Rick. Rich is actually watching the show rather than
I'm on the wall of shame, not fame.
Here we go then. So who are we going to start with, young man? So you can talk if you got. Remember,
I've only got 2. I've only got 2 names.
Oh no, you've got 3. Surely you got 3. There'll be another one up there.
Rick?
We had a disaster here, Rick. What have you done wrong? Rick, is there 3? So okay, just okay.
If you haven't got mine, that's quite.
Oh, he's got it. He's got it.
One there.
Yeah, look.
Down there.
Yeah, come on, Gilf.
Ooh,
right, Grandad. Where are we going? Who you can start with?
Well, we'll have to start with Alex, I think.
It's not a good sign, Alex.
No,
it wasn't terrible.
It's not that bad.
If it was the Olympics, would you say this was a bronze medal out of the 3 of them?
Yes. Well, not bronze. No, I don't think it'd be anywhere near the podium. So he actually did this in.
It's rubbish.
It's okay. 6 minutes 47.
Okay. Yeah, that's proper in no idea territory.
That's David sell tools sort of territory.
Yeah,
that
absolutely. So,
test equipment, tools.
I thought not kitchen. What are they called? Fitters. What fitters is he? He's shop fitters. You had to get in and out.
It's not shop fitters.
Go on. What is it?
Retail construction.
I thought you had to get in and out. You have like 48 hours to do a whole shop.
Quick. Yeah, but look at
right now. It's getting a bit tighter now. Who are we going for next?
It's going to be a challenge. It's going to be a challenge.
Who are you going to go for?
I think we're going to have to go for Spike. Actually.
Ooh, Spike. Now that could be a terrible sign. Now you didn't move very quickly. What football position did you play?
Centre back.
Wow, that did surprise you down as a little winger, little nifty winger, but you're at centre. You're not the tallest. How tall are you?
I'm not. I think 5'11".
You think?
Yeah,
it is your height. You've owned it for a while, and you're guessing your own height. Right. So 5'11" looks like you can put is he down there? Is he on this board?
He is on this board.
Well done. That is outstanding. That is outstanding. That is.
He's actually in. You're in. I'd say older-aged electrician territory.
What?
Down here.
Okay.
Yeah,
it's got a competitive streak.
Lee Brody, Library Lee.
Library Lee?
Library Lee. Faster than Library Lee.
Oh, well done.
You're actually faster than Stephen Buckley, who hosts an Electricians podcast out in Ireland.
Oh, does he? Are they trying to find out who is international? Yeah, international. Who was it? Gone? You're nodding at.
Sadly, yes.
Yes, international trades personality
4
of the
minutes
year.
and 30 seconds.
Feel free to get your votes in for yours.
Just below Steve Parsons there with arthritis.
Okay, this is a good sign, I would suggest. Richard, how do you think you got on? You're very competitive. Just so we can get a live view of it. So, no, come on, let's have a little look. I didn't get to touch it.
Look.
Wow, look at
that. That's polished. That is polished.
Any reason why you've only lost part of it?
That's stress, that is.
Is it from retiring at 53 on a full pension of your final salary?
What am I going to do tomorrow?
Yeah, absolutely. So, are you going to be on that board? Is he going to go and stay on that board?
He is still on this board.
Joking me. Oh, it's close.
Oh, I'm low.
It is close. But it's not close enough.
It's not close enough?
It's actually 4 minutes 43, just below Callum Jackson there with a turkey teeth.
So we can say tonight's winner
He's Spike.
Spike. Well done, Spike. You did brilliantly.
Thank you.
Now, if you want to be good at something, have brilliant hand-eye coordination. Plays hockey, played football at an absolute elite level. Okay, might have got cut when he got to 18 and all the rest of it. And you'd never really held a screwdriver. It just shows you that if you've got the competitive edge and hand-eye coordination, you can do it. And yours was really good as well, Alex. Yours was pathetic.
Thank you.
Absolutely. I think we were nearly 10 minutes first time round. We lost interest, we did. So, yeah.
That was
It's all
terrible.
good. Yeah, OK. So happy days.
When you were doing retail construction, you weren't on the electrical side, were you? Just supervising or something, was it?
I was supervising.
Oh, promoted out of trouble, we call that.
Yeah. Was that in Australia as well? Was that in
No,
Australia?
that's here in the UK. So I was opening retail stores for Swarovski at the time. All over the country.
Swarovski crystals, Gary.
I've never heard of it.
Jewellery.
Oh, right, OK.
Yeah.
Not those healing ones for Mystic Megs, not that type of crystal.
Not that sort of crystals.
And binoculars.
Or the
yeah.
meth.
So,
Yeah, no, OK, just checking. Right, well, we can take it now. That was really exciting 10 minutes for me, that was. What do you want to do next, G-Dog? You've got to talk, nobody's at home listening to telly. Yeah, well, just think and talk at the same time. You can just casually say stuff, can't you? You can say how well Spike's doing. Yeah, I'm on the telly, the International Personality Tradesman of the Year, or whatever it is. Just.
I really hope. Yeah. We hope he doesn't win. Because if he does, it's right. Oh, we'll never hear the end of it.
It's the personality bit. I mean, you've got to go head to head. Yeah, if you want to, we can do a live 1 hour face-off maybe with the semi-finalists. We can all take a mic and we can all have a go and we'll see how we go. If you're in the audience, my jokes will be endless. Okay, I can just your face is like an archaeological dig. Yeah, that type of stuff. We can do all those ones. Right, so where we go next? You want to take some questions for the audience? They've been banging their way through.
Yeah.
So I know we've got.
I mean, loads of people saying on rapid shutdown systems and things like that. Should they be mandated on solar installs?
They are in the US, Philippines. I mean, select countries have gone down the rapid shutdown route, but there's also a pushback from the central string inverter. Keep a system simple. The least points of connection is the least points of failure. So we're agnostic. PVStop, our focus is first responder life safety. There are a number of electrical solutions trying to fix an electrical problem. We're a non-electrical isolation tool. That's the best way I can describe us. But we have to be agnostic. So, like I said, there's one solution doesn't fix all the different variables from a root cause point of view. We look at it from consequences. If we can mitigate the risks around the consequences, that's part of our job done. And then it's really about us now trying to collaborate with other solution providers to find a safer way to take solar forward. We all want safer solar. We need more solar. The ambitious plans we've got under net zero is going to see exponential growth. We don't want to see an exponential rise or increase in incidence. And we don't have to. We have the solutions available. What we need is collaborative and a comprehensive approach to dealing with that risk mitigation side.
Yeah, it all comes down to education, doesn't it? Once you know the solution's out there, you can't mitigate the problem because you actually know there's a solution.
Every single installation will need to be assessed on its own merits. So the points that Richard were making on fire risk assessments, risk assessment generally needs to improve, that education piece. Underwriters, brokers from the insurance, they need the same education. They need to form that basis and the data behind it to make more informed underwriting decisions that will support risk mitigation, that will then support safer solar. We all want that. So it's how we get there, and what we're trying to do with PVStop is just saying there's a very simple, safe and effective way to completely de-energise a PV system.
Practical note. Yeah, Gary, can you pick up one of those?
Yeah. Okay, which one would you like me to pick up?
The bigger one.
The bigger one.
Yeah.
Okay, this one?
No, the bigger one.
The bigger one. Okay, yeah.
How many kilos is that?
That's 14 kilos.
Right, so how many panels?
That will cover 100% up to about 18 to 20 panels.
Right.
But with the education, you can actually, with the knowledge of the right type of panel, you can spray 40% across the midsection of a solar panel, and that's enough to break the circuit. It's like Christmas trees back in the good old days, the old days, bless us. But when you used to take one out, that all the lights in the string would go out. Whereas now, Christmas lights, when you pull one out, they all run in parallel. So you can pull one out, put one back in, and all the lights stay on. A solar panel works like the old school Christmas lights. So as soon as you knock out one section, 40% is what we've tested and been verified. We went down that kind of verification route with the EU Environmental Technology Verification Programme, which is a mouthful, but that was all that was available at the time for us as a novelty. We don't fit within existing regulations, standards or classifications. We had to forge our own path. Richard and London Fire Brigade were instrumental in taking that safety leadership position that helped us validate our solution without having any regulations in place. Rapid shutdown, you look at what they've done in the US, the Philippines, the amount of money they've had to spend to get their solution regulated is tremendous. That's lobbying, political influence. That costs a huge amount of money. We're 3 people with a solution that punches above its weight. We can't afford to go out and buy that level of policy influence or regulatory support. That's where the validation from the first responders, the firefighters, the biggest global safety agencies in the world, London, Singapore and New York, have all validated our solution. But the solar industry, the electrical industry are still going, we're not the solution. We are part of the solution. We have to be.
Come. Yeah, like you said, we're behind Australia. We're behind these countries, with our adoption, but we've got to get there. So.
Someone's saying, Gary, remember the good old days when there were just chip pan fires?
Yes, I do, yeah. And when you went to the little experiment, they took like a pipette, didn't they, and just put a pipette into the water into the chip pan fire, and it went up like a good one. Yeah, okay, we've all seen that demonstration.
Remember those days, Richard?
Yeah,
I do, and we don't encourage that anymore.
Oh, we don't do that?
No, we don't. No, we used to display, we don't do it anymore.
No? Right, okay.
So you used to wet a tea towel, wasn't it? And then
Cover
floor
it
that
over,
over?
yeah. So cover it over, withdraw, call the fire brigade.
Oh, I know why they've stopped doing them, because I used to go on a Saturday to see that display. I suppose that's a day you don't work, isn't it? It's like, another one of those.
We're 24/7 service.
Yeah, but you don't work more than 7 hours out of 24 days, though, do you?
Well, I think you'll find we do.
You've retired at 53 on a final salary pension. Did you manage to draw the pension at age? I'm really personally curious about that.
I did manage to draw
So
it.
you drew it at 50, did you? Were you in the original scheme then?
I was in the original 92 scheme.
Okay, so when you're a
joined in
teacher,
97.
like my wife,
Yep.
she was in the original scheme and the government just kicked you in the absolute and said you'll have to start the new scheme. So you were fortunate enough to be left in your scheme.
So we had to go to the court and apply for it, and we won the case, thanks to the Fire Brigade Union, and the police also followed. So I don't know about the teachers.
Well, obviously didn't do anything, did they? They just carried on working really hard and teaching people, didn't they? Whereas you spent most of the time in court, didn't you?
Vocation.
One that doesn't pay.
Teachers.
Yeah,
But
okay.
you're not risking your life on a paperclip, Gary.
No, nah, not anymore. Nah, it's fantastic. So, any other
You've got
questions?
an air fryer now.
Yeah, I've got an air fryer. Yeah.
Do air fryers have any fire problems with air fryers?
It'd be electrical faults, I imagine, but obviously...
That's usually when you don't know what the fire is. Let's get to it.
I've not got a clue about the specifics.
Yeah.
But we'll turn up. If you have a problem, we'll turn up. Don't worry about that.
Well, you won't. Well, you're retired. We won't have you there. Perhaps your boss will come.
You're very hurt about this.
Oh,
aren't you?
no.
He never goes on about it more than 3 times a week, actually. So
Just wondering whether I'll get any nominations for International Trades Personality of the Year.
yeah.
Right, go on in.
More
Gene.
cock-a-line.
Have we got any more?
We have been on 91 minutes.
Yeah, okay. So, again, I guess it's been absolutely fantastic today. We will be doing social posts to jump you back into different segments. So if you joined us towards the end of the live stream
You'll
and you're
want to watch
thinking
the
what
fantasy
happens,
football.
you want to see the fantasy football. That's coming in a minute. Yes, okay, we do know that one as well. I was going to dump that one, but we can go back to that. We're going to roll through a couple of assets. We've got an amazing end song. And, of course, there will be an opportunity for you at some point to vote for International Trade Personality of the Year. Let's go to the fantasy football.
Game week 11 is over and out in the eFIXX Fantasy League. And let's be honest, it wasn't one to remember for most managers. Arsenal conceding for the first time since September set the tone, wiping out clean sheets left, right and centre. It was a tough one across the board. If you scraped over 40 points, you've had a good week. That says it all. But don't panic, plenty more game weeks to come and still time for redemption. Let's dive in. We kick things off with the Marshall Toughlex Team of the Week, which goes to Tesco McNeil deal, Mutassim H. Mutassim made a smart call using his bench boost, racking up a superb 76 points, almost double the game week average. Take one look at that bench and it's like a points buffet. Great management, great timing, and for once, a bench boost that actually worked. Most of us activate it and immediately regret it. Next up, the EV Blocks Defence of the Week goes to Living Demeanour Loca, George Walsh. George pulled 26 points from his defence on a week where clean sheets were basically extinct. That's seriously impressive. Top effort, George. Next up, the Fusebox Flyer of the Week goes to Ginger Warriors, managed by Paul Tipton, a familiar name for regular viewers of the eFIXX channel. Paul climbed 64 places up the table into 163rd, powered by picking Michael Keene in defence, who delivered a monster 15 points. Great work, Paul. You've lit up the table this week. Finally, the TIS transfer of the week. Okay, so last week's pick, Gabriel, didn't exactly go to plan. But this week, we're due a winner, and my money's on Mateta against Wolves. Wolves have looked ropey all season, and if ever there was a fixture for a forward to get himself on the score sheet, this is it. That's the highlights from Game Week 11 in the eFIXX Fantasy League. Huge thanks to our brand partners for backing the fun. And don't forget to enter the draw for the eFIXX Tool of the Week. Links in the description. Until next time, may your captains actually play, may your benches be stacked, and may Leeds continue to disappoint Rick.
If you joined us on our first live stream we did today, you'll understand how incredibly stressful tonight has been for us, but not since we've been live. Thanks to Alex, Spike and Richard, this has been one of my most enjoyable and educational journeys that I've had on a live stream, where I've earned and learnt lots as I've gone along this journey. And from your would-be international personality of the year, electrical industry biased person, good-looking, handsome person sitting next to G-Dog, I wish myself all the luck in the nomination process, and I will see you in 2 weeks. Tune into the end song. Bye-bye!
Panels on rooftops, sun in the sky, but something's wrong and we can't deny. Fires rising, risks unknown. Behind the promise, sparks have grown. Cheap parts, bad fits, corners cut, install flaws hiding in the gut. Every fuse, every wire could feed a flame, could spark a fire. Too hot to ignore, too close to home. We've got to fix this, can't face it alone. From roof to breaker, and to start, safety first, must guide the yard. Side of crew worn, insurance track, it's time to take